Okay, I am recording. So where we left off was overloading methods. We talked about that. Just the idea within a class, you can have multiple methods with the same name as long as they take a different set of parameters. And that way, the application flow, the execution flow knows which method to go to. Okay, so for example, if you're calling the print screen method, print line method, and you're sending along a string, there's one method for that. If you're sending along a number, there's another method for that, right? So the execution flow knows which way to go. Okay, next up, object declaration and creation. Okay, so in order to be used, an object has to be given a name and its data fields have to be given values. Okay, so there's two steps to this. First part is declaration. In declaration, you're giving the object a name and a type. For example, string S. Then the IDE is going to know that there's this thing called S that is of type string. And that just lets the IDE know what object is being referenced when it's compiling the code, right? So when the IDE gets that declaration, it says, oh, S is going to point to a particular location in memory, okay? And then it knows what to do with that when it's actually doing the code compiling. Creation, on the other hand, makes the object usable, okay? So if you've declared something, the IDE knows that the object exists, there's a reference for it, but it hasn't filled out all the details about it. Okay, so if there are no, if there are any data fields in it, those haven't been created yet. They haven't been filled out with numbers, whatever. It's not available for use, and you can't use the object methods because the object hasn't been created yet. So creation makes the object usable. And before it's been created, it's what's considered null, which again means that it exists. There's a reference in the IDE, but its data and methods are not yet usable. So let me write that up in Paint because I can do some annotation there. So hopefully you all can see Paint. So if I do something like string S, and then later on S equals new string word, okay? What happens at this point, S has been declared, okay? That means we can use it as a reference, for example, when creating the object. Okay, so down here, right, we have this S equals new string. Without this declaration ahead of it, we wouldn't know, the IDE wouldn't know what S was. Okay, so I'll say the declaration is needed so that Eclipse knows what S is. Okay, and then this part is creation. Here we say S has been created. It is a fully formed new object and can use object methods. In the case of strings, some simple ones are like length, for example, and has data. In this case, the text word. Okay? So anytime you want to use an object, anytime you want to use an object, you have to declare it, then create it. Okay? All right, so let me pause this for a second. Recording. Okay, so here we are in Eclipse. Let me close that out. Let's make a new, oh, maybe I didn't upload those things the other day, scope and overload. I should upload those. Okay, let's make a new class. And I'm going to call it, I don't know. Sorry, I'm a little bit off here. Declaration, creation, example. Okay, and I'll give it a main method. I would just call it DCE. DCE. Better. Okay, we'll give it a main method, and boom, there we have it. Okay, so this is our class. I'll put a note up at the top. Declaration, creation, example. Okay? So, DCE, let's give it two strings, string S and string T. And initially, they exist, but they haven't been filled out. So what we know, we're going to create a couple things. So we're going to create a DCE object. So DCE equals new DCE. Okay. So here we're combining the declaration and creation in one statement. Hold on. I'm not entirely, I gotta move this window a little bit so I can see what I'm doing. Statement, okay? So that's what we're doing. So this part here on the left, the DCE that I'm highlighting, that's the declaration. This part on the right, DCE equals new DCE, that's the creation. Okay. Anyway, this is a standard syntax, you can do this. But if you wanted to keep it very simple, right, you could, of course, do this, and then that, and that would also be fine. But we like to combine things on one line when we can. Okay, now every DCE object, and I'm going to make a note here, because every DCE object has the two strings S and T, they exist but are null. Okay, so at this point, we've created the DCE object, but we haven't created the individual strings that it possesses as data. So we could print out system.out.println DCE.s plus DCE.s. Okay, we'll actually print out the contents of the string. And what will happen is it will be null. Okay, and then I'm going to put here application end. Okay, so we'll run that. And see, there it is. It's null. It doesn't exist. Okay, so if I try to do something like display the length of S via an object method for S, okay, I could do system.out.println DCE.s.length plus DCE.s.length. Okay. At this point, the IDE is not smart enough to realize that although DCE.s exists, it hasn't been created yet, I can't call the length method on. So this is going to make the program crash. That's okay. Boom, we get exception in thread main, this thing null, we get what's called a null pointer exception. That means we're trying to read an attribute from a null object. Well, the object hasn't been created yet, so none of its data fields can exist yet either. If we want to avoid that, let's do this. Let's actually create the string. Create the string DCE.s. Okay, so DCE.s equals new string and I don't know, your mama. Okay, so what's the length of your mama? Well, there's 10 characters there, so it should be 10. Let's run that. Okay, boom, the length is 10. So now that the object has been created, okay, since the object S has been created, we can use its object methods and object data. Okay. So I'm going to save that. Stop the sharing for a moment and we'll pause it. And I'm going to share. Again, we'll share everything. Boom. Okay. So back to the slides. So we'll do a little bit of slideshow here. I got to slide that over too. Okay. So declaration and creation, we understand those. Now, most objects are created using the word new. If you want to create a new object, basically what new means is you're creating a new object at some new point in memory, not previously used by something else, right? We're just emphasizing the fact that we're creating a new object. For example, if you have this class object, which is the foundation class of all objects in Java, and you want to create a new one somewhere else, well, that's how you do it. Now, there are some quirks here that we'll get into as time goes on. The first one, strings are a special case. You have the option of not using the word new, but it actually, in some cases, has an important consequence. We'll talk about that a little later in the string chapter, the string lecture, and then later on in the Booleans as well. Another quirk, same object can have multiple names. So just like in real life, I have multiple names, right? My parents call me Doug, my kids call me Dad, and students call me Professor Lundquist, and my wife calls me, I don't know, El Stupido sometimes. Yeah, you have different names for the same thing. All that means is when objects have different names, they're different references, but they're pointing to the same spot in memory, and thus they're pointing to the same thing. Just like the example I gave the other day when I was talking about sending parameters to a method. If you're talking about an object in that case, all right, so let me put that in paint briefly. Let's put that in black. If I have a method that accepts a string, which is an object, okay, so void method string s dot 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 whatever, right? Code goes there. If I have a method that calls it, so I'll say string, I don't know, t equals word, and then I call method and I send along t, okay? Here's our block of memory. I'm gonna draw a little, okay, fine. I'm gonna draw a little box for t in here somewhere, okay? This is where t is, t pre-exists. So when I call this, right, the t I'm sending along is that t, but likewise, when it receives it as a parameter here, when it receives it as a parameter here, same thing, it's also pointing to t, okay? So s and t in this case are actually pointing to the same thing. They're just different names for the same thing. Okay, and this allows it, right, if we didn't do it this way in Java, why this is important, if we didn't allow multiple names for the same object, we would have to specify the method separately for each object we might send. And that's kind of ridiculous, right? If you're talking about a big banking application that might have millions of users, and every time you send a username and password to a method, you'd have to code that up separately. That would be insane, right? So the ability to send objects generically to methods is a huge and wonderful development. It makes life much, much simpler. Okay. Anyway, so those are the quirks. Moving on. So standard syntax, declaration, and creation. So again, here we have some code here. So declaration gives an object a name and a type. So we have string s. That just means the IDE knows s is an object of type string. It's been declared, has not yet been created, so it's not yet usable. With creation, we give data values to the object, and generally we allow the use of object methods as well. We're essentially making the object real. When we declare it, it's just an idea, but when we actually create it, we've made it real and usable. So the line s equals new string hello, we're sending along that, that text, and we're creating the new object, string object containing the text hello. And then last, you know, just here, display the content of s to the program console. So we print it out and it'll print out hello. And this, you know, if you like, this is a very simple program, right? It's got a main method, we run it, it creates a string and it displays it, ta-da, does something. Okay. Now, of course, you can have multiple object names. So for example, in the method here, we have, or in the slide here, we have two classes. So there's one class called class and there's another one called class 2. Class just has a method, class 2 just has an int as data. So again, a reasonably large integer, about plus or minus 2 billion is the range on that. So first of all, we create a new object of class 2. So we create this new object called C2 and we set its x attribute to 5. So second line there, C2.x equals 5. At that point, again, we've created the C2 object and we've given its initial x a value. Okay, if we didn't give it a value, it would be defaulted to 0, but we give it a value, so now it's 5. if we create, or if we declare another class 2 object, so here we say class 2 C3 equals C2, that means not that C3 is a copy of C2 or that C2 is equal to C3. What it means is C3 is C2. So essentially, the reference C3 points to the same part of memory as the reference for C2, and thus all of their data values are going to be the same because C3 and C2 are in fact the same thing. Okay, so you'll also notice when we created C2, we called a constructor method to make a new thing, right? We said new class 2. But for class 2 C3, we did not, because we're not creating a new thing. We're just borrowing an existing reference. So the last line of the comments there, because C3 is C2, C3.x will automatically be 5 because C2's x attribute is 5, and C3 is C2. Okay. Some other odds and ends here, semicolons, commas, braces, quotes. These are things you'll see as we go along. Some of them we've certainly already seen. This will give you a little bit of a feel for how they're used. So individual statements end with a semicolon, right? You see that throughout the code examples I've done. Commas, which we haven't really seen yet, I believe, separate related portions of a compound statement. But one place where you might see them is if you're accepting multiple parameter types in a method. Then you'd separate the types by commas. For example, string S, comma, string T, comma, string U, whatever. There's other places they come in as well. Braces, or the squiggly brackets, braces surround groups of statements, often called blocks. Now, in general, for clarity, nested braces should be indented, and the IDE will do that for you. Okay, it's an automatic default setting. So if I create a new class here, so I'll do, I don't know, syntax example. Automatically, if I create a method, right, if I go to the next line here, I hit tab and I go to a new line. If I create a new method, so void method 1, whatever, it automatically creates that action, right? So for example, one thing I might do, I could give it some, a couple of attributes. So int x and then int y, and now make a constructor method here that accepts a pair of ints. So syntax example int x int y, and I'll say this dot x equals x, this dot y equals y. And the reason why I'm using this here is to distinguish this x from this x. Okay, so if I highlight this in the IDE, you can see that this other x gets highlighted, right? So the parameter within that method is just referring to x. But this int x here that's a data field, that's this dot x. So that's one place where I say in constructors in particular, the this is often useful. And there's other places too. We'll talk about that a bit later. Okay, so what I've done here in terms of the indentations, automatically both of the methods end up inside the class definition. Now, if I wanted to, right, I could just shift all this left, okay? But then it's a lot harder to read, and you can imagine as you start getting methods, and those methods have their own braces within them for various purposes, right? So suppose I have a for loop in here. So I'll say for int I equals 0, I less than 999, whatever, I plus plus. I'll say system.out.println I. For no good reason I'm doing this. I'm just demonstrating. If you have a lot of text and a lot of brackets, it gets pretty hard to read on the side where everything lines up, right? You're like, oh, is that part of that one? Yeah, I guess so. And this is part of, I guess, that. If you do the nesting, okay, it's just much easier to read. And it'll help prevent errors, right? It'll help prevent errors by things like missing braces. One of the most common errors in early coding of Java is you miss a brace somewhere. And that can be an error that's very difficult for a novice to find, because what happens is the errors that light up in the margin here, they don't necessarily respond to the point where the brace is missing. Okay, so the best thing you can do is set up your framework of methods first and then fill out the individual methods. that'll help out a lot with, it'll make it unnecessary to debug a lot of problems. Okay, so that's braces. Last, quotation marks. So there's two kinds of quote marks, double quotes and single quotes. A double quote in Java refers to a literal text string. Okay, so like we've done when we sent some data to a string, like here, new string hello. The word hello is encased inside double quotes. That means it's a string. Java recognizes that as a string. If it's just within single quotes, okay, so let me say like, I'll do it in a notepad, I guess. Like this A, this is a single character, which is essentially a number. We'll talk more about that in a couple of lectures down the line, which is essentially a number. Okay, this is a string, which is an object. Okay. All right. So that's it. Last thing, all quotes need to be uncurled, right? So if you're writing up your code in Microsoft Word or something, you might see that Microsoft automatically wants to turn your straight vertical quotes into curly quotes. So that's a bad idea. That can happen. It's a very common problem when you're borrowing code, because people will write code in Java and they'll post it to the internet, but they'll edit it in a Word document. And so when they post it, the quotes will be curly. So if your quotes are straight like this, if you do them in some plain text editor, you'll be all good. But if you do them, let's see if I have it set in here. No. If you do it like this, I guess I just lift this one, right? This is a different character, and the IDE will not appreciate the variation. Okay, so that's curly quotes. If you do that, the IDE won't put up with that nonsense. Okay, so if we look at our string example here, where did we have that? DCE? Yeah, we had that in DCE. If we replace any one of those quotes with a curly quote, we get an error for that. It's like, I don't know what you're trying to do there. Okay, so don't do that. Be aware. Same thing for single quotes, by the way. They also have to be straight up and down vertical, like in this single character example. Okay. Comments, we've seen comments before. Comments aren't executable code. They just help explain what particular code does. So single line comments are indicated by a double forward slash. That means everything to the right of the double slash on that line is not going to be executable. That's just going to be some explanatory code about what's going on. Okay, there are a couple of other comment styles. We'll get to them, but this is enough for now. Okay. Constructor methods. We've seen constructors. A constructor is a special method that automatically creates a new object. Now, a constructor may or may not accept parameters. You can write it so it does or so it doesn't as appropriate. One quirk about the constructor is it has the same name as the class and is case sensitive. So again, we've seen examples I've written most recently in this syntax example, I guess. No, in the DCE. Okay, this is, where's my... Oh, there, it was in syntax example. Got thrown there for a second, right? This is the constructor, has the same name as the class. I'll even make a note for that. Constructor method. Okay, the other thing that's interesting about the constructor is it has no return type. Okay, so if I, for example, put in a void syntax example in that previous code, Java would just think that that's some ordinary method that happens to have the same name as my class, but has no special significance beyond that. So, you know, the idea why a constructor doesn't have a return type, the return type is the same name as the method, right? So when we call this method, if we think about this in our IDE for a moment, if we say syntax example SE equals new syntax example, okay? Essentially, I have to cover that in a second. Let's see. I don't know, 1, 2. We're saying here SE accepts, right, is assigned the reference of the new syntax example, right? So we're saying this constructor method, in effect, returns a syntax example object and it assigns it to this SE reference. All right, so we know a constructor method is always going to return an object of that type, so we don't write it in there. We just say, okay, you know what? This is it. This is it. This is the method name. Okay. Now, all classes have at least one constructor. But if no constructor method is coded, there's going to be a default constructor provided. And if any constructor methods are coded, the default constructor is no longer available. So what does that mean? Well, here I've created a constructor method, right? I can build this object. I've set that up. If I didn't have that, so let's get rid of this for a minute. We can restore it lately. So here, this gives an error. I'm going to get rid of this as well. Okay, and I'm going to say syntax example SE equals new syntax example. Okay, I can call this constructor. At this point, it's using the default constructor. The default constructor doesn't take any parameters and doesn't do anything, right? It's just, in effect, it's going to assign zeros to all these data fields. Or if I wanted to, I could put like numbers in there. They'd be assigned a definite number, but it's not going to do anything special beyond that, okay? If I want the constructor to do something, for example, like say print out a message that the new object has been created, then yeah, I would put that in the constructor method. Anyway, so the constructor method exists as long as I haven't specified another one. The default constructor exists, but once I do that, let's bring it back to where we were. If I wanted to just call this default constructor, even though I have a new one, guess what? I get the error, I can't do it. It says this constructor is undefined. Once I create any constructor method, then the default constructor is no longer available. It's basically a way of saying, you created a constructor, you must have had a reason for that, people should use it. If you want to have a do nothing constructor, at that point you have to code it in yourself. Okay, so it's a little bit of a quirk of Java, but it is what it is. Okay, I'll leave that back where it was. Okay. Now, with constructors, the actual object creation happens behind the scenes. You don't need to do any extra coding for that. Java's going to take care of that for you, which is a nice thing. Okay, you don't have to set it up. Okay, so coding with constructors. Here, this first one, we have a constructor without parameters, class. It doesn't take any parameters. Code goes there. We can also have within the same class a constructor that does take some parameters. So this one takes a couple numbers. And then depending on which constructor method I called, the execution flow would either go to the first one or the second one. Okay. Last thing, let's see, we got a few slides to deal with and we got just enough time to deal with them. So we're going to talk about inheritance. Okay, so anytime you create a class in Java, it forms part of an inheritance hierarchy. What does that mean? Well, let me explain. So first of all, give you one note. The root of all Java classes is object, okay? Every class you create is either a subclass of object directly, or else, make that a new line, or else a subclass of a subclass of object. Okay, now you may all be thinking, okay, that's nice, but what's a subclass? So yeah, fair enough. What's a subclass? Well, a subclass does a couple things. Basically, a subclass is a more detailed version of the superclass, right? What it was based on. Let me give you an example. So suppose I have a superclass vehicle, okay? There's a few things I know about a vehicle. Number one, by definition, a vehicle is mobile. That's what distinguishes it from a paperweight. So a vehicle might have as attributes, right? As data, it might have speed and direction, right? It's going at some speed in some direction. Even if that speed is 0, you know, it's stopped, but it still has a speed and a direction. Likewise, it would have methods. And again, since a vehicle by definition can move, it would have methods start and stop. Okay, so any vehicle, if it's actually truly a vehicle, is going to have those attributes. Of course, we know there are many different kinds of vehicles. So I'm going to label this as a superclass. Okay, and maybe vehicle descends directly from object for that matter. So I'll just, make that line. Okay, now there's going to be different types of vehicles, right? There could be a truck. A truck is a kind of vehicle, right? Or there could be a speedboat, right, which has direction but does not have wheels. Or there could be, what else? I don't know. I'm being very whatever. I'll say a car. No, let's say a balloon. A very large balloon, right? One you can ride in. So any of those might have their own special attributes. For example, balloon might have the special data height, right? Because they fly up and off the ground. Speedboat, for example. Well, what's special about a speedboat? Well, maybe speed is measured in knots, but I'm thinking one of the things for a speedboat, you might look at something called draft, right? How deep it sinks into the water, basically. And that's not going to be an issue for these other types. And trucks, okay? Trucks, a typical thing there might be wheels, right? Because your speedboat and your balloon will not conventionally rely on wheels to get around. So we might, for a truck, have air pressure as a data bit. All right. So the point is, subclasses allow greater specific detail of some base core type, okay? A more detailed version of the superclass. And in general, we know a couple things. Generally, the subclass would have more data and more methods, or at least not fewer, compared to the original superclass. So for example, object has a few methods and it doesn't have any data that it keeps. Okay, so that's what a subclass is. Now the nice thing about this is what's called inheritance. Inheritance is the idea that when you create a subclass, you automatically can use all the data and methods of the superclass. Okay? This makes it faster, much easier to use a subclass. And we'll see this especially in graphics, where there's a lot of features built into the classes that we actually use. So it's much faster to write, much easier to use. And what else? Vastly reduces coding errors, okay? Because you don't need to rewrite everything. Okay, most of it you just get. So let me give an example in Java, right, in the IDE. So if I want to make a subclass of syntax example, I use the magic word extends. So class syntax example, okay, 2. And there it is. So here I'll say syntax example 2 is a subclass of syntax example. And I do that by putting in the magic words extends syntax example. Okay, and then I have this neat thing. So why am I getting an error there? Oh, I got to give it a constructor. So I lost my old constructor. So fine. Syntax example 2 ... Nah, it's still giving me hassle about that. Fine. I just borrow the one you got. I just call super. What? Fine. I'm just going to do it this way then. What is going on here? Fine. And make it public. All right, fine. I'm gonna drop this. It's being a little quirky today. Okay, so we'll leave it like this for the moment. Okay, so the point is, with syntax example 2, I'm going to inherit the same stuff. Okay, so I automatically have an X and a Y. So I can give it a method, void method display, void display. And I'll say system.out.println this.x. Sorry, I was doing some weird stuff here. And system.out.println this.y. Okay, and the reason why I can do this is because it actually has them. Notice that even though syntax example 2 doesn't have the X and Y, right? It inherited them from its superclass syntax example. Okay, so they're there, and that's a handy thing. And you can see the same sort of thing with methods as well. Okay, so anyway, so subclass inherits data and methods from the existing superclass. Subclass typically adds more data or methods, and superclass cannot have data or methods not present in the subclass, with the exception of private ones. We'll talk about that when we get to visibility, but for now, trying to keep it simple. Another quirk, constructor methods aren't inherited. So you saw that's what I was wrestling with there for a second, is you don't inherit the constructor methods, and sometimes, yeah, there's issues with that. Okay. So, example. So inheritance only works in one direction. You can make a subclass of an existing class, but you can't make a subclass of a superclass of an existing class. So when you graph all of the classes that exist in Java, they're all going to make this massive tree with object at the root, right? So ultimately, for any class you have in Java, the superclass will eventually be object. Okay, and just like we talked about writing classes before, the appropriate model for a subclass is application dependent, right? So if you're trying to model trucks as inventory, that's going to be very different from if you're modeling trucks as smart vehicles on the road. All right, when we invoke inheritance, when we make a subclass, we use the magic word extends. And again, class can only directly descend from one class. If you think about it for a second, it makes a lot of sense. Because if you inherited from two classes, what would happen if both of those classes had the same method name or the same data, right? You wouldn't have a good way to pick which one you were actually inheriting from. So, and you'd have to inherit one but not the other. It would create problems. So that's essentially why inheritance is important, what it's good for, how it works, all that. Now, one thing that's worth noting, although you're going to inherit the data or the methods, it doesn't mean they have to be specified in exactly the same way. For example, in this example, I have class, it has an object X and a string Y. If I wanted to, I could make a subclass of class 2, and I'd still get X and Y, but I could give them different types. For example, I could make this X a string and this Y an object. And you could do that. It has to inherit the X and the Y, but you can give them different types. Okay, and you can do the same thing with methods. If the superclass has a method name, the subclass will have that method name, but it can be specified differently for the subclass. And that's eventually going to be an important thing we'll talk about toward the end of the course with something called polymorphism. Okay. So let's take a moment, do some knowledge checks. If people want to stick around for a couple minutes, I'm happy to discuss some of this stuff. So these are the things you should know, right? You don't have to be a Java coding expert at this point, but you should understand the basics. What are classes and objects? What is a project? What's a package? How are class data and methods distinguished from object data and methods? Hint, it's the magic word static. What's included in a method header? You have the three things. You have the return type, the method name, and the parentheses containing the list of parameters the method accepts. Know the difference between object declaration and creation, what they do, what they're for, what's a constructor, what's a default constructor, right? How is the default constructor different from non-default constructors? What are superclasses and subclasses? And for any of those things, know the syntax. Okay, that's about where you should be at this point. So I'm going to stop the recording, but if people have questions, again, I am happy to discuss.
I just had a quick question.